My name is Vivian Labrie, and I'm an associate professor at the Van Andel Institute. I'm going to tell you about our new study where we find a potential target to better treat Parkinson's disease. Parkinson's disease is a severe neurodegenerative illness that involves motor and non-motor symptoms, affecting over 10 million people. In our study, we wanted to better understand the molecular changes happening in the Parkinson's disease brain in order to come up with better therapies for this disease. We studied epigenetic marks known as DNA methylation. These serve as molecular switches to turn on and off genes, which ultimately affect the way that cells function. In our study, we isolated brain neurons. These are an important workhorse in the brain, and in Parkinson's disease, some of these cells die to cause the symptoms of the illness. We found that in brain neurons, there were DNA methylation abnormalities that affected the survival of neurons. And in another data set, we found that there was a high level of inflammatory activity in Parkinson's disease brains. All these processes are important for the progression and development of symptoms. Interestingly, we found an abnormal function of a gene called TET2. And this is important because it's a master regulator of DNA methylation status, the molecular switches that we were finding altered in the Parkinson's disease brain. TET2 can be important for both the survival of neurons and inflammatory processes. Our most remarkable finding was that when we eliminated TET2 activity in a model system, we found that neurons that would otherwise die in a Parkinson's disease brain were fully protected from the damaging effects of inflammation. We saw that reducing TET2 activity both protected the neurons and reduced levels of inflammation in the brain. Overall, our study has revealed an entirely new target for the treatment of Parkinson's disease, which is based on molecular changes that are happening in the brain of these patients. This is really exciting because this target has the potential to both protect neurons from dying and to lower levels of inflammation to better treat Parkinson's disease.